Okay, so the second part of 4.3 today, we have the theorem 4.5, the definite integral as the area of a region. It just says if f is continuous and non-negative. The problem with negative, you saw yesterday when we had our graph that looked like this. And we had this area, and we had this area. Oops, sorry. This area. The area on the left is larger, yes? Yeah. And since it's using negative numbers, it's going to come out negative, but is area ever negative? No. So we have to do some adaptive procedures to our techniques when we get a problem like that. So we end up with a positive area plus a positive area. Okay. So on a closed interval A to B, then the area of the region bounded by the graph of f of x and the x-axis and the vertical lines A and B, so these vertical lines that are imaginary right here.
They're not imaginary, you just move them.
Yep. Is the integral from A to B of f of x dx. So instead of using the limit version, the limit method to find the area, I can integrate. And right now, you know basic integration. So every problem you did yesterday, you could have used basic integration on.
Because you didn't use basic integration.
Okay.
Why did you write down twice?
So sketch the region corresponding to each definite integral, then evaluate each integral using a geometric formula. Okay. So, what kind of equation is 4? So, y equals 4.
Is a constant.
Straight line.
What kind of a straight line?
Linear straight line.
What kind of linear straight line?
Horizontal.
Thank you. So, I'm supposed to graph it.
I don't care now.
So, 1, 2, 3, 4. So, here's my horizontal line.
Yeah, it is.
Okay. And I'm using, so it's from the horizontal line to the x-axis. And what numbers on the x-axis are we using?
4. No, all of them.
No.
1 and 3.
1 to 3. So here's 1, 2, 3. So we're doing this box. What shape is this?
A rectangle.
A rectangle.
Oh, I guess that one's rectangle.
So rectangle is length times width.
Wait.
So what's your width?
Our width is 2.
2. And what's your length?
4.
4. So what's your area?
That's a bit advanced.
8.
See, I was just hoping somebody else was going to say it.
She did.
Nobody else did.
So today you're not going to be using integration. You're going to be using geometric formulas to integrate. Okay, so now we have y equals x plus 2. So how do I graph that?
As a line,
So how do I graph it?
well, your intercept's 2. And goes
So I go up to 2.
And you're going from 0 to...
And I'm going from 0 to 3, right?
So you don't have
So if I plugged in 3, wouldn't it just be easier to do? Okay, so if I plug in 0, I get 2. And 1, 2, 3. If I plug in 3, I get what?
5.
2, 3, 4, 5. So here to here. And my line goes through it. But I'm going from 0, 0 to 3. Now, I personally cut this into what 2 shapes, do you think?
Probably a triangle and a rectangle.
A triangle and rectangle, and add them together. The book actually does the whole shape together as a trapezoid, but I'm going to tell you, nobody in this room, I remember it because I teach it every year. Do you remember the area of a trapezoid? No. Do you know how to get the area of a triangle and a rectangle?
Sometimes.
Not really.
Well, you should. Okay, so a triangle is 1/2 base times height, correct? Rectangle is base times height. That's a B. Don't look at the man behind the curtain. Okay,
I want.
so you want to do rectangle or triangle first?
Rectangle.
Okay, so the base is
3 by 2.
3 by 2, so 3 times 2
Yeah.
plus 1/2. What's the base of the triangle?
3.
3, and the height of the triangle? 1, 2, 3.
And
Yeah. So I get 6 plus 9 over 2. So 12 plus 9 is,
21.
so 21 over 2. And just so you know, area of a trapezoid is 1/2 the height times base sub 1 plus base sub 2. But
Thanks.
wasn't it easier just to do what we did? Yeah. Okay, now we have the integral from -2 to 2 of the square root of 4 minus x squared. Well, what shape is that?
Square root.
Well, 4 minus x squared is a circle, yes?
yeah.
So the square root of it would be how much of it?
Half
Half a circle. And the way you draw it is what happens if I plug in -2, which is the lower limit. What do I get?
Negative.
Get 0.
0.
And you get 0.
And if I plug in 2, I get 0. So I probably better figure out what I get when I plug 0 in, right?
Yeah.
So when you plug in 0, you get 2. So there's your half a circle. Okay, so a circle, what is its area? What's its formula?
Circumference pi over 2 r pi.
Looking for area, not circumference.
That's what I said the first time.
So did you say it?
I don't know, did I?
I don't know. I didn't hear it.
Base times height.
It's a circle.
Pi r squared.
Pi r squared. So we're going to do 1/2 of pi r squared. So 1/2 of pi, and what's your radius?
2.
2. So I think I get 2 pi. What do you think?
I think that you're right.
Okay, so today, all of your areas you're going to find are going to be with geometric shapes. Because why would you integrate when you could just do a geometric shape, right?
I don't know.
Questions?
No.
Okay. So if you can make triangles, squares, and rectangles, can you make pretty much everything?
Yeah.
Triangles, rectangles, circles, sorry. Okay, so some rules we need to know. If f is defined at x equals a, then we define the integral from a to a. Wait, how far do we go from a to a?
None.
None. So guess what the area is?
None.
0. These were on your final when I said those were extra credit, or on that last test or quiz or whatever. These are things that were on there. Okay, so from a to a, your area is 0. Or the integral, the definite integral is 0. Same thing. Finding the integral, you're finding the area under the curve. Okay, if f is integratable on a to b, then we define b, the integral of b to a of f of x dx. Now you notice it's b to a. Which number comes first? Or which letter comes first?
A.
A to B. It should be from A to B, right? So you switch it to A to B, and you put a what in front of it?
Negative.
A negative. So if you get something that has the bigger number first, you switch it and put a negative in front. Now this last part of your assignment is using just these rules.
Well, then I better write them down.
Mm-hmm.
So I can look in my book to remember what they are. I still don't remember what I was going to tell you later.
Let me know when you're done, Natalie.
There's 3 squirrels in a line. On the other side.
Natalie, are you done yet? Like, what are you writing? You only need the integral part. She's writing out every word. Function of x. Derivative of x with respect. No, derivative with respect to x.
Okay, I did write that out, but I'm done now.
Okay. So the next one is if the integral from a to b can be cut in the integral from a to c plus c to b. So that means that c is between what? A and B.
Well, I'm not supposed to write the words this time.
I would.
I wrote the words and I still got done at a reasonable time. Which was like twice as fast.
So we would use this particular problem if I ran into something like this and said this is A and this is B. What is the problem with me asking for the area from A to B?
You don't have
There's that thing in the middle,
This thingy in the middle, which makes it what?
0.
a non-complete, it makes
It's
it non-continuous.
non-continuous.
Discontinuous.
That's what I was saying.
And we cannot integrate something that's discontinuous, correct?
Because the thing is there.
So instead of going from A to B, we would go from A to
To see.
0, which would be our C, and add it to
0 to B.
0 to B, which would make it possible then.
Are we done?
Well, you should have some examples, evidently. Let's go back and do some.
End of slideshow.
No.
Okay,
We're done.
so I could make it done if you would like.
Well, I don't know.
Okay, so the integral of pi to pi of sine of x dx. What's the answer?
0.
0.
Pi. Oh,
Ah, you silly.
Why is it 0?
this is from A to A.
It's from A to A.
So that makes it 0. Oh, you tried that.
So 3, the integral from 3 to 0 of x plus 2 dx. How do I rewrite that one? It'd be negative the integral from
3 to 0.
0 to 3 of x plus 2 dx.
Why is it negative?
Hmm?
You switch the,
Because we switched the a and the b.
What rule is that?
That was the second rule I gave you. The one that you wrote out in words.
I just made it harder, okay?
Okay, so I have the integral from -1 to 1 of the absolute value of x dx. So we probably should look at it. Doesn't this look like this?
it'll be 0.
And from -1 to 1, we have the problem.
You have -1 to 0, and 0 to 1.
So -1 to 0
That's the absolute value of x.
Oops.
dx.
plus 0 to 1.
Absolute value.
And we could figure that out pretty easily, I think.
Is that all we have to do today?
Yeah, but we're going to figure this one out.
I thought
This is a triangle, yes?
Yeah.
And is this a triangle?
Yeah.
Yes. So 1/2 base times height. So 1/2, well, the base is 1,
1,
and the height is
1,
1. So I get
a half of 1.
a half plus a half is,
Yes, Natalie, 1/2.
and I think we answered this one already, yes?
Which one?
Didn't we do x plus 2 in your examples?
We did do that exact one.
So the answer with this would be negative what?
Negative 21 over 2.
-21/2. And we would do that by drawing that picture, and that was a trapezoid shape, wasn't it?
It was, yes.
Okay. So let's see. Next property. I don't know why I don't have these in there.
I don't know either.
A to B of k of f of x, k dx. Okay, k is a constant. So what can I do with it?
Put it in front.
I can put it in front, just like our summations. So it would be k, the integral of a to b of f of x dx. Okay. Am I going too fast?
Yes,
Yeah.
for Kale.
Well, because I was speaking.
Sorry to have bothered you.
Yeah, should be.
So the next one I have is the integral from a to b of f of x plus g of x.
This is another thing.
So how would I do that one? Same way I do a summation, same way I do a derivative. I take the integral of f of x dx and add it to the integral of
G of x dx
g of x dx.
would be appropriate.
Just slow on this time.
And I think that's all you need.
Just writing over some words I'm writing.
So using the properties, when you have an example, did I just give you odds? So I'll give you an example of
Of nod.
how they would use these. So they're going to tell you the integral from 2 to 6 of x cubed dx is 320. And they're going to tell you the integral from 2 to 6 of x dx is 16. And they're going to tell you the integral of 2 to 6 of dx is 4. And then they're going to ask you something like the integral from 2 to 6 of negative 3x dx. So what can I do to that?
You can just,
Can't this negative 3 go out in front?
yeah,
So I have negative 3, the integral from 2 to 6 of x dx.
equals 16.
So it's negative 3 times 16. So negative 48. So the integral from 2 to 6 of 21 minus 5x minus x squared cubed dx. What do I need to do with that one?
Break it apart.
Break it apart. So I have the integral of 21 minus the integral of 5x minus the integral of x cubed. Oops, all of these have what behind them? And they all have 2 to 6s. I just didn't want to write them all. Then what?
Then, what else was it constant?
What happens to the 21 and the 5?
Well, they move out.
They move up front. So I have 21 times the integral of dx minus 5 times the integral of x dx minus the integral of x cubed dx.
And you just put in basically
So I have 21 times
4,
4 minus 5 times
16
minus,
320.
so 84 minus 80,
So
so a 4
16.
minus 320, so negative 316. So that's how you're going to be doing them.
That's not too bad.
All right, so you have some shapes you have to draw in that, but then other than that, it says use the properties. Well, this is how you're using the properties. Okay? I think I'm done.